In this lesson, I will go over how to calculate slope by looking at a line that's already graphed. I've already mentioned this in a couple other lessons if you've started to view them, but the slope of a line is defined as a fraction. So it's always going to be a number, and we always want to put it in fraction form. And that tells us how slanted a line is going to be. So slope, no matter where we're going to use it, whether it's looking at a line that's in slope-intercept form, we're going to refer to the variable representing slope as m. And the fraction that it describes to us is rise over run. Rise is just the up or down movement. It's telling us the change in y's, the change in the y values. Over our change in x's, which is our run. And our run is going to be a horizontal change. So we're going to say it's over the change in x's. In a separate video, I'll go over what we call the slope formula, and that's just using an algebra format in order to calculate this rather than looking at a line that's graphed, because we're not always going to have that option. For those of you that have already seen slope in an algebra format, the change in y is the symbol is this Greek letter. It's really delta. It looks like a triangle. But change in y's over change in x. We could also say delta y over delta x. But I'm mainly going to be focusing on these two words using rise over run. And we'll look at some that are graphed. But next I want to talk about the four directions of a line. So we could see, we always want to read, just as we read words, sentences rather, left to right. So if I have a line that goes uphill left to right, I indicate that this line has a positive slope. So this line is going uphill left to right. Or it's increasing as we move from left to right. So any line that's in this direction, in this northeast direction as we move from left to right, is considered to have a positive slope. Any line that is going downhill, left to right, is going to have a negative slope. So we say this line is going downhill or decreasing from left to right. The other two directions are if we are looking at a horizontal line, this, we say the slope is equal to 0. If you take a look here, we have, think of just all the numbers that exist. We have positive numbers, we have negative numbers, and if a number is neither positive nor negative, it's 0 then. But a slope is 0 is for a horizontal line. And here there is no rise. There's run. There's only a left to right movement, but there is no up or down movement. It is strictly just no rise, but there is run. And then the fourth direction is a vertical line, just straight up and down. With these, we say the slope isn't a number. We say the slope is undefined. We use a word to describe this because one way I kind of look at this is you could stand on a hill that's going uphill or downhill. You could stand on flat land, but on this vertical line, there's no defined or definite place to stand, so slope is undefined. A lot of times you might come across the phrase no slope, which is, like I said, it's used with this, but I don't want you to get confused with the slope of 0, so I always like to stick to the word of undefined. And then this is a vertical line. And I go back over this in my lesson on horizontal and vertical lines. So in this particular case, we have a rise, we have up and down movement only, but no run, no side to side movement. So looking at these, I'm actually going to change these colors back because I had this with red before. I want to kind of keep it color-coded here. So if I'm looking at all three of these lines, notice we are going uphill from left to right. So this is this positive direction or positive slope that we're looking at. In order to calculate slope from a line, we want to find two very good ordered pairs. So if I'm looking at line 1 that's here, say I have a very nice point here, and I also have one here. So if we can go through and kind of keep making some points, we'll be able to count here. So for number 1, I want to just kind of say that m is going to equal, remember I want rise over run. So my rise here, I'm going to start at this point right here. I'm going to count up 2 blocks. So that's my rise, which is 2, and over 1 is my run. And if you notice, I can go up 2 again. So from here, I can go up 2 and over 1. So I'm looking at a rise of 2 and a run of 1. So I have a positive 2. We could leave it as 2 over 1, or we could just say 2. And again, it's going to stay positive because we're going in this uphill movement or increasing from left to right. For example 2, I'm going to put a point here, say here, here, and here. Now if I counted here, I'm going to count starting from this point. I can go up 1, over 1. Or if I started right here, I can also go up 2, over 2. We're always going to put our fractions in lowest terms anyway. So here I have a rise of 1. I'm going up 1 and over 1. So here my slope is going to be 1 over 1. If I looked here and I said that my rise was a 2 over a 2, 2 divided by 2 still simplifies to 1 over 1, or I have a slope of just a positive 1. And then in my third example, I'm going to put, let's say, a point here. This spot right here is not a very good point, not until I get to maybe right about here and then here. So in this case, I'm going to go up 1 and over 1, 2, 3, 4. So I have a rise of 1 and a run of 4. So in my third example, I have a slope. My rise is 1 and my run is 4, so 1/4, and I can't do anything else with it. Now I'm actually going to erase this a little bit, and I just want to show you, because what if you were looking at a slightly different direction? Again, the easiest way is to go from left to right, but what if you decided to start at this point right here and you decide to go down 1? So I have a rise. Since it's down 1, it's really going to be a -1 down. Then I'm going to go 4 to the left. Well, because I'm going 4 to the left, it's going to be a -1 over a -4. And what's a negative divided by a negative? That's going to give us a positive. So in the end, it still turns out to a 1 over 4. So I just wanted to show you that we don't always have to go in the same direction. It is going to be easier if we always do go from left to right. But in this case, we were also able to go from right to left, just showing us if we go down 1, it's going to be negative, and then 4 to the left, it's also negative. And whenever you get 2 negatives, they turn back into a positive. So these were all examples that had positive slopes. Next, I'm going to take a look at the first 2 examples here. Notice I color-coded those as well. So here, any type of line that is going in this downhill direction or decreasing as we go from left to right will have a negative slope. So starting with example 1, let's see, I want to put a point here, and then it looks like we have another one here, also here. So if I started, I'm going to go down 1, 2, 3, it looks like, over 1. Now I want to change that a little bit. I was a little bit off at the beginning. I think the point is best put right here. All right. So here, if I count down 1, 2, 3, 4, and over 1, so I'm going down 4, but 1 to the right. So my rise is going to be a -4, but my run, so I'm going down 4, and then 1 to the right. So my run is a positive 1. If I repeat that, 1, 2, 3, 4 down, and then 1 to the right. So for number 1, my slope is going to be a -4 over a 1, which we could leave like this, but it also turns into a -4. If you wish to pause this now to try your hand at number 2, go ahead and do so, and then click resume to figure out or see what the result is. So number 2, I'm going to put a point here. Let's say I've got another one here, and then another one here. Those look like some good points. So I am going to start at this point right here, go down 1, 2, 3. So I have a rise of -3 and then a run of +2. So my rise is -3 and my run is a +2. So for number 2, my slope is going to be -3/2, -3/2. It could also be written as -3/2, where the negative is sort of in the middle of it, or technically we could say 3/-2. As long as we have a negative somewhere out in front, it will be correct. But again, both of these lines are going in this downhill direction from left to right, so we would say that we have negative slopes for both of those. Now, a couple ways to look at the next 2 examples. Here, I could put points anywhere on this line, but the easiest way to sort of spot this or identify this is to say, well, we have a horizontal line. So if you look back at this page, anytime we have a horizontal line, there's no calculation necessary. We say we just have a slope of 0. And I didn't really color coordinate this, so let me just change this real quick. I'll do that here too. Okay, so for number 3, we will just say our slope is 0. Likewise for number 4, doesn't matter where I put points. I don't have any slant to it whatsoever, so in number 4, our slope is also 0. And these next 2 examples are what type of lines? If you said vertical, you are correct. So again, it doesn't matter where I put points, as long as I recognize that these are vertical lines. The slope of a vertical line, if you go back a few pages or back in the video, see what word I used to describe this. So for number 1, M, our slope is undefined. Again, because these are 2 vertical lines. So also number 2, our slope is undefined. A lot of times you might see this abbreviation, just UND, for undefined. Now on this last page, I have 5 lines that are graphed. Again, if you wish to pause this, find some points on here that are nice points, and then click resume, continue to see what you're coming up with for the answers. So in number 1, if you said our slope is undefined, you are correct. It is a vertical line. For number 2, put some nice points here and started counting. It looks like we can count down 1. So our rise would be a -1 and then 1 to the right. So our slope is going to be a -1/1, which is just a -1. In number 3, we have a horizontal line. Our points are just lining up horizontally. So here our slope M is 0. Number 4, we have a line that's going uphill left to right. Let me find some nice points here. Let's see where we had them. All right, so here I can count up 1, 2, 3. So we have a rise that is 3, and then over 1, 2, 3, 4. So number 4, we have a slope that's +3/4. And in number 5, put some nice points here. It looks like we can count down 2. So we have a -2. And a +1 to the right. So in number 5, we have a slope of our rise is -2 and our run is 1. So overall, we could say that that has a slope of -2. So I hope this helped a little bit for looking at how to calculate, just by looking at a line that's already graphed, how to calculate slope. Again, if you have any questions, feel free to email me at help@thealgebratutor.com. Thank you.